Geometry, segment lengths, and midpoints. That's lesson 1.1, and we'll be doing a warm-up to see if you're ready. So there are about 3 parts to this. There's an algebraic representation of transformation, and there's an angle relationships, and they're asking about complementary and supplementary angle. In case you forgot that, you could do me a favor and just look that up if you forgot what that is, and also the supplementary angle. And there's also the finding the distance and the midpoint of the given 2 points. Okay, guys? All right. Why don't you pause this video and try this problem out? Okay. I'm going to assume that you've finished, or at least given a fair chance to. Sorry. It's early in the morning and I'm kind of tripping over my words. Okay, guys, here's the answer for the first one. When you have an equation and you want to shift up this way, you're adding to a y value, right? So whenever you have this shifting up, you add to y value. Because the equation equal to 5x, that 5x is in terms of the y value, you add 3 more to that. That's how you move up, right? And in this particular case, we're stretching, right? Stretching is doubling, tripling, that's actually a multiplication, right? So if it's a factor of 2, you multiply vertically by 2. So you multiply the equation by 2, which gives you 10x. This one was asked by the book, but at this point I would rather avoid it. So if you spend too much time on it, I apologize, but it's good to think about it. But it has something to do with if it's a horizontal, you actually do something to the x value. As it turns out, you subtract instead of adding when you move to the right. It seems counterintuitive, but you would learn that in Algebra 1 and Algebra 2, depending on a textbook, x minus 2. And then there's a scale factor of 3, and you will multiply to the front over here. So I would rather not get into that at this point. But it's covered fairly thoroughly in Algebra 2. Okay. Alright, guys. In angle relationships, this right here means sum of the angles is 90 degrees. Then the 2 angles are complementary. So hence the answer is 70, 55, and 23. And supplementary means what? That's right. Sum of the angles is 180 degrees. Hence, the answers for the 7, 8, and 9 are 100, 115, and 146. Now, when you're asking about the distance and the midpoint formula, well, here it is. Okay. Now, if you think about what this distance formula is, if you really think about that, right, it's actually, if this point right there is x1, and this point right there is x2, and this point right there is y1, and that point there is y2. And you could connect like this, right? So this is a change in x and this is a change in y. The distance between these 2 points is a distance right there. What shape does that look like? Exactly, it's a right triangle, isn't it? If that's the case, that tells me that it's d squared is equal to change in x squared plus change in y squared. Well, what is the change in x? Change in x is a difference of x1 and x2 and x1. Hence, that's what that is. And what is y? That's the difference between these two. Top minus the bottom. That's what that is. So all you have to do is square root both sides, and that is what we end up with. So that becomes this right there, guys. Okay. So this is nothing more than a Pythagorean theorem. Okay. The midpoint, right? The midpoint is, let me put that in a different color, right? It's midpoint between these two. But if you sort of think about it, in terms of x coordinate, that is the average of these two values. And this point right there is the average of these two values. That's why this equation looks like this. When you add two different values and divide by it, that's an average, isn't it? That's right. So the midpoint is the average of x and average of y. So if you go through the calculation, so that's number 10 right here, guys. The distance between the 6 and the 1 is 5, isn't it? And the distance between 14 and 2 is 12. So all I did over here is I used a Pythagorean theorem. And that adds up to 169 right there. If the d squared is equal to 169, we square root both sides. D must be 13. Okay. And the midpoint of these 2 points is the average of x and average of y. So if the average of 6 and 1, that's how you find it, which is 3.5. Average of y is 14 and 2. Divide by 2, which gives you 8. So you go through the same kind of exercises for number 11 down here, guys, right? And you end up with 17 for the distance, and for the midpoint is 23/2, comma 10. Okay, we'll get into the more specifics in the class, but that was a warm-up. Hopefully you remember all that from Algebra 1. Okay. All right, guys. So let's take some notes. Okay. Make sure that you have your annotated note in front of note printed out in front of you. So this is from the blank. Okay. What is a point? Well, point is a specific location. It also has no, can anybody tell me what that is? No dimension. And it is represented by a dot. While it has no dimension, we have to physically see what it is and we have to denote it. So we try to denote it with the smallest thing that we could do, which is basically a dot or a point. So hence the point, right? So the geometric figure will be like this. We denote it with a little dot, that's A, or maybe a little dot and a P, and that will be called point A, or in this case, point P. You could literally spell out the word point, but it's generally accepted that it's okay to put PT, period. All right. What's a line? Line connects. It's a connected straight path. There's no thickness. It continues forever in one direction? No. It is both direction, right? So basically, if you have a point, let's say, A and B, you would have arrow going in both directions. That's how you indicate both. Guys, right? Both. The arrow goes this way and this way. Okay. And we may have 2 points that go through that, or we may just label it L. So how do we name them? The ways to name the figure, there are a couple different ways. Actually, more than a couple. We could literally say line L. Or literally line AB. Right? Because this line goes through points A, B. And oftentimes you'll find that the symbol is basically a miniature drawing. So the last one that I'm going to offer you is this. Oopsie. It's a AB with a miniature line above the letter AB. Yeah. All right, a plane. And it's a good idea for you to try to anticipate what I'm going to say, and that helps you sort of stay engaged when you're learning online. Okay. A plane is a flat surface. It has no thickness. It extends forever in all direction. Okay. So we draw the figure. We denote the plane with a, imagine this is the top of the desk. And we would usually do that by drawing a parallelogram. And we usually put capital letter right next to it. Right? P, Q, R are like the most common letters that we use. Or the way we could sort of name it is literally write plane P. That is it, guys. Okay. All right. So we're going to define some terms. The one before that, actually, I'm sorry, is what we would call, it's interesting, it's called undefined terms. Yeah, it has a definition, right? Here are the defined terms. Okay, maybe I just brushed off that a little bit too fast. This is sort of like things that are obvious truths, right? I'll just leave it at that. I don't want to go too much into that, or it just becomes a big rabbit hole, right? And define terms. We're defining the term line segment, or simply segment. It is actually a portion of a line consisting of 2 points called, the 2 points is called, can you guess? That's right. It's called endpoints. And all points in between them. So basically, it's this portion, AB. If I go back to the previous picture, right here, it's this portion of the line that's called a line segment, right? Hence the word portion. Okay, so you might want to circle that if you wish. So it sort of reminds you that that's the key feature, right? It is a portion of this, the line segment that has 2 endpoints. Okay, and the way we denote that is literally say segment AB. But for those of you who grew up texting could attest, no one really writes out the word segment AB. Mathematicians, kind of like young teenagers, in that we don't want to write too much, right? So how are you supposed to do this? If you guess that the symbol for segment AB is pretty much a miniature version of the image you see over here, you're absolutely correct. So we just put a little, so you don't have to put the endpoints, you could just draw a simple, like, let me just go back, right? You could just do that. And that would be segment AB. Array is a portion of the line that it starts at a point. See that? It's a single point. A point called, that's right, endpoint. And continues forever in one direction. So it is a part of a line. Well, we really couldn't say half of a line simply because something that's infinitely long, how do you say something's half, right? But it is a portion, but it does have just one arrow, right? It has one direction, right? So once again, we could literally write the word ray AB, but as you know, we like to put a shortcut to that. It is draw a little ray on top of the letter AB, but be careful. In this particular case, that's the endpoint, means that A is the endpoint. And what that means is that the line, ray goes through point B. Let me give you a different scenario though. What if you had a point C here? right? The alternate name for this is also ray AC. As long as you have the endpoint and a point that ray goes through, we're good. So the ray AB and ray AC in this particular case denotes the same ray. Okay. All right, guys. And a few more. This is written out for you guys, but here we go. Points are coplanar if the points lie on the same plane. If I could offer you a quick definition, the word CO, COM, COL, right? Con, com, co, col, right? It's all the same word. It just, we change the spelling a little bit so we could pronounce it a little bit better. It just means the same. Its prefix comes from Latin word, right? And it means the same or together, right? That's what it actually means. And planar, as you could tell, means plane, so it's in the same plane, right? So once you feel the root words, it's actually a lot easier. The points are coplanar if the points lie on the same plane, right? The name says it all. Lines are parallel if two lines lie on the same plane but do not intersect. The key is same plane, because it is possible for something to do not intersect but not parallel. Can you think of what that is? It's called skew. Skew lines are two lines that do not intersect and are not on the same plane, right? But you could think of parallel as something like because it has been the same plane, think of a train track, right? Yeah, that's probably the best way to think about it. Two lines are parallel if they're on the same plane but do not intersect. Okay? All right, guys. We got two more. We got points are collinear, or COL means the same, right? On a line. We're in the same line. Yep. Something's called collinear if the points lie on the same line. And a postulate, this is a very, very, very important word. It's a statement that is accepted as true without proof. In other words, this is so true. Actually, what's the word that my professor used? Yeah, that's right. This is some people call it assumed truth, right? Or better yet, to take a little spread from our Constitution, it's a self-evident truth that all men are created equal. All right, this is a very famous phrase that we have, right? So that is it, guys. Why don't we wrap it up over here? We actually have some more to do, right? This, and we will finish this up in a classroom. Okay. All right, guys. Be sure to submit the what you have annotated into the Canvas for the participation grade. Okay. All right, guys. Have a good night.